Okay, so let's get right into it. While you've probably been hearing all about large language models, there's been this other, quieter revolution happening in the world of robotics. And it's a big one. The entire foundation of how we teach robots, the data they actually learn from, has been completely flipped on its head. And this quote, it just says it all. This signals a massive, seismic shift. For years, just having a unique set of robot data was a huge competitive advantage. But now, the game has totally changed. What used to be super valuable is now, well, it's just a commodity. So how did we get here? Not that long ago, the robot data scene was honestly a total mess. It was completely fragmented, scattered across hundreds of different university labs and company research centers. Every single team had its own little data set in its own weird format for its own specific robot. It made building on anyone else's work practically impossible, and yeah, it really slowed things down. But then something interesting started to happen. A kind of Matthew effect took hold. The idea where the rich get richer. In robotics data, this meant a few huge, well-funded projects started sucking up all the oxygen in the room, all the attention, the downloads, the citations, and this wasn't an accident. To train the smart, general-purpose robots we all want, the field desperately needed to get organized. It needed scale, and it needed standards. This consolidation, it had to happen. And all that consolidation gave rise to three dominant ecosystems, three data titans that pretty much define the landscape today. So let's break them down. We're going to look at the massive real-world data project called OpenX Embodiment, then the open source toolkit LaRobot, and finally the incredible world of large-scale synthetic data. Right, first up is OpenX Embodiment, or OXE for short. And this thing is seriously ambitious. We're talking about a giant team-up between 34 of the world's absolute top robotics labs. Now, the analogy here is what's really important. If you follow AI, you know the name ImageNet. It was that enormous, standardized image dataset that basically kicked off the entire deep learning revolution. Well, Oxame is trying to be exactly that, but for robotics. A universal, foundational dataset for any AI that has to interact with the physical world. And the scale is just mind-blowing. We're talking over 1 million real-world robot attempts, or trajectories, from 22 different types of robots. But here's the magic trick. Standardization. It takes more than 60 different datasets and wrangles them all into one common, easy-to-use format. And the impact? Basic stuff like picking up a block. The data for that is now basically free and available to everyone. It's been commoditized. So let's move on to our second titan, and you'll see how this builds. Now, Oxay is pretty closely linked to Google and the TensorFlow world, right? Well, the Llama Robot ecosystem, which comes from Hugging Face, has become the go-to standard for the massive open source community that uses PyTorch, TensorFlow's big rival. And this is the key difference. LaRobot is way more than just a dataset. Think of it as a complete toolkit. It's got the data, the models, and the code to train them. It's all designed to make it way, way easier for anyone to get their hands dirty with real-world robot learning. It's all about opening things up for the whole community. LaRobot also brought some really smart technical ideas to the table. This might sound a little geeky, but by switching to modern data formats like Parquet and MP4, they made datasets 5 to 10 times smaller and faster to load. And that's a huge deal. It basically forced a strategic shift, making these efficient formats the new industry standard. If you're not using them now, you're already behind. Okay, so we have real-world data pretty well covered by Oxay and LaRobot. But there's a third, equally powerful force that's popped up, massive-scale synthetic data that's generated entirely inside a computer simulation. And the best example of this is a project called Internata A1. This thing is really pushing the limits of what you can even do with simulation. Just look at that number. Let it sink in. Intern Data A1 has the equivalent of over 7,000 hours of nonstop robot experience. I mean, can you imagine trying to collect that much data in the real world? It would be astronomically expensive and take forever. But in a simulation, it's possible. And it isn't just about the sheer amount of data. The real magic here is the diversity of the physics it can simulate. We're not just talking about wooden blocks anymore. Intern Data A1 simulates the messy, complex stuff that has always been a nightmare for robots: pouring liquids, folding cloth, handling ropes. And the crazy part? For simpler tasks, this synthetic data is now just as good, if not better, than the real thing. Which brings us to a pretty dramatic question, right? If we can just generate endless, perfect, automatically labeled data in a simulation, is real-world data obsolete? Have we just solved the data problem for good? Well, not so fast. The answer to that question lies in this fundamental, really stubborn problem that has haunted robotics for decades: the unforgiving gap between simulation and the real world. See, what works perfectly in a clean, predictable computer simulation often fails spectacularly in the messy real world. And it happens for four big reasons. There's the dynamics gap. Real-world friction is just weird and unpredictable. Then the perception gap. Real cameras have noise and lighting issues simulations miss. There's an actuation gap. Real motors get old and wear down. And finally, the system design gap. Simulation doesn't care about things like network lag, but a real robot definitely does. And this chart, wow, it says everything. You can train a model that gets it right nearly 100% of the time in the simulation. But then you take that exact same model and put it on a real robot, no other changes, the success rate just plummets, often by more than half. That, right there, is the reality gap in action. So the verdict is in, and it's pretty clear. For anything truly complex, like folding laundry, or assembling something with tiny parts, or just working in a messy house, you simply can't rely on simulation alone. That dream of a perfect, zero-shot transfer from sim to real, it's just not here yet. Real-world data is still absolutely irreplaceable. So where does that leave us? Well, it means we're moving into a new, much more sophisticated phase in robotics research. You could call it the post-dataset era. The smartest people in the field are no longer just asking, which dataset should I download? They're asking much more clever questions. This completely changes the game. For a startup, the challenge isn't having the biggest dataset anymore, it's having the smartest data strategy. For researchers, it's a shift from just collecting data to carefully curating it. And the answer that's starting to emerge is that the future belongs to these hybrid datasets. The winning strategy seems to be use massive amounts of synthetic data to learn all the basics, and then fine-tune your models with small but incredibly valuable and targeted real-world data to handle all those complex tasks where simulation just can't keep up. The new competitive edge is knowing the perfect recipe to blend the two. So if there's one thing to take away from all this, it's this. The great data consolidation has already happened. The titans are here. But that was really just the end of the beginning. The truly fascinating work is just getting started, as we move from simply collecting data to actually learning how to cook with it. The question is no longer which data set. The real question is, what's the perfect recipe?